Hello my viewers, you're welcome once again. In this video we're going to solve this exponential equation, and it says what is the value of n that satisfies the following equation: 2 to the power of n times 4 to the power of n times 8 to the power of n times 16 equal to 2 to the power of negative n times 4 to the power of negative n times 8 to the power of negative n. To solve exponential equations like this, we need to be able to express the terms given to us in index form. For example, the index form of 4 is 2 to the power of 2, since 4 is 2 times 2. And the index form of 8 is 2 times 2 times 2, which is 2 to the power of 3. That of 16 is 2 times 2 times 2 times 2 in 4 places, that is 2 to the power of 4. So if we apply it here, that means our equation, which is originally 2 to the power of n times 4 to the power of n times 8 to the power of n times 16 equal to 2 to the power of negative n times 4 to the power of negative n times 8 to the power of negative n. So applying all of this here will give us 2 to the power of n times, since 4 is 2 to the power of 2, so I'll have 2 to the power of 2, then multiply by the n there, which is n2n rather. Again, 8 is 2 to the power of 3, so I have 2 to the power of 3n there. And 16 is 2 to the power of 4, 2 to the power of 4, equal to 2 to the power of negative n times 2 to the power of negative 2n, since 4 is 2 to the power of 2, and the negative multiplied by negative n will be negative 2n. Multiplied by 8 is 2 to the power of 3, so I have 2 to the power of 3 times negative n. I have negative 3n. Now applying the first law of indices, a to the power of m multiplied by a to the power of n is a to the power of m plus n. So if I apply the law here, we have 2 to the power of n plus 2n plus 3n plus 4 equal to 2 to the power of negative n plus negative 2n plus negative 3n. Okay, and we know that positive multiplied by negative is always negative. So on this left hand side, right hand side rather, we have it as 2 to the power of negative n, plus times minus is minus, I have minus 2n there, minus 3n. Okay, then on the left hand side I have 2 to the power. I can add up this. Let me add them up right away. N plus 2n is 3n, 3n plus 3n is 6n. I have 6n, then plus this 4 equal to this. On the right hand side I can also add negative n, negative 2n, negative 3n. Like it's just like saying minus 1, minus 2, minus 3. Of course, when you have negative numbers like this, you add everything together and put negative sign in front of it. So 1 plus 2 is 3, 3 plus 3 is 6, so this is negative 6. So that means I have 2 to the power of 6n on the left hand side plus 4 equal to 2 to the power of negative 6n. Since negative n, negative 2n, negative 3n, that is minus n minus 2n minus 3n is minus 6n. So now in indices, when solving exponential equation, if the bases are the same, we equate the powers or the indices. On the other hand, if the powers are the same, we equate the bases. So in this case, the bases are the same. We have 2 here and 2 here. So we are going to equate the powers. That means 6n plus 4 is equal to negative 6n. Now if we collect like terms, this negative 6 here will cross to the other side. So we have 6n. Of course, when negative crosses equality, become positive. So I'll have plus 6n equal to, again, this 4 here. This is positive 4. When it crosses equality, become negative 4. So, and 6n plus 6n is 12n. So 12n is equal to negative 4. To get the value of n, we need to divide both sides by 12. So dividing through by 12, I have 12 to cancel out. So I have n equal to, of course, 4 is a factor of 12, so we can divide through. 4 here 1, and 4 here 3. So our final answer is negative 1 over 3. That is the value of n that satisfies the equation 2 to the power of n times 2 to the power times 4 rather, to the power of n times 8 to the power of n times 16 equal to 2 to the power of negative n times 4 to the power of negative n times 8 to the power of negative n. I hope you found the video useful. If you do, don't forget to like the video. Also, subscribe to the channel so you get notified when I release a content like this. Thank you.